هنستأنف هنا تاني. Regular and even expansion of bed does not always occur when particles are fluidized by a liquid. This is particularly so for solids of high densities, and non-uniformities are most marked with deep beds of small particles. In such cases, there are significant deviations from the relation between bed voltage and velocity predicted by equation 6.3. Segregation in beds of particles of mixed size. When a bed consists of particles with a significant size range, stratification occurs. يعني بتبقى تعمل طبقات. With the largest particles forming bed of low voltage near the bottom, and the smallest particles forming a bed of high voltage near the top. If the particles are in the form of sharp cut size fraction, segregation will be virtually complete with what is in effect a number of fluidized beds of different voltage, one above the other. If the size range is small, there will be continuous variation in both composition and concentration of particles throughout the depth of the bed. It has been shown experimentally that a mixture of equal masses of 1 millimeter and 0.5 millimeter particles, when fluidized by water, will segregate almost completely over the whole range of velocities for which particles of each size will, on its own, form fluidized bed. If a mixture of large and small particles fluidized by a liquid, one of three situations may exist: complete or virtually complete segregation with a high voltage bed of small particles above a bed of lower voltage containing large particles. Beds of small and large particles are described in A, but separated by transition region in which the proportion of small particles and the voltage both increase from bottom to top. A bed in which there are no fully segregated regions, but with the transition region described in B extending over the whole extent of the bed. If the range of particle sizes in the bed is small, this transition region may be of nearly constant composition with little segregation occurring. هذه المناظر عندك هنا ايه؟ عندي هنا حاجة اسمها bed inversion. فأنا عندي بقى هنا مزود inversion point، وبعدين يبتدي بقى small يطلع فوق يعني صغير. في عندي هنا برضه inversion point increasing velocity. فأنا عندي complete segregation هنا complete and partial segregation اللي عندي هنا في الحتة دي. Gas solid system general behavior. In general, the behavior of gas fluidized system is considerably more complex than a liquid fluidized system, which exhibit a gradual transition from fixed bed to fluidized bed followed by particle transport without a series of transition regions, and with bed expansion and the pressure drop conforming reasonably closely to values calculated for ideal system. Part of the complication with gas solid systems arises from the fact that the purely hydrodynamic forces acting on the particles are relatively small compared with frictional forces between particles, electrostatic forces and surface forces, which play a much more dominant role when the particles are very fine. طبعا very fine يبقى surface area كبيرة. As the gas velocity in a fluidized bed is increased, the system tends to go through various stages. Fixed bed in which the particles remain in contact with one another and the structure of the bed remains stable until the velocity is increased to the point where the pressure drop is equal to the weight per unit area of the particles. تاني حاجة بقى particulate regular predictable expansion over limited range of gas velocity. وبعد كده a bubbling region characterized by a high proportion of the gas passing through the bed as bubbles, which cause rapid mixing in the dense particles. A turbulent, chaotic region in which the gas bubbles tend to coalesce and lose their identity. A region where the dominant pattern is one of vertically upward transport of particles, essentially gas-solid transport or pneumatic conveying. This condition, sometimes referred to as fast fluidization, lies outside the range of true fluidization. Particle fluidization. Although fine particles generally form fluidized bed more readily than coarse particles, surface-related forces tend to predominate with very fine particles. It is very difficult to fluidize some very fine particles as they tend to form large stable conglomerates that are almost entirely bypassed by the gas. In some extreme cases, particularly with small diameter beds, the whole of the particulate may be lifted as a solid piston. The uniformity of the fluidized bed is often critically influenced by the characteristic of the gas distributor or bed support. Fine mesh distributors are generally to be preferred to a series of nozzles at the base of the bed, although the former are generally more difficult to install in large beds because they are less robust. Bubbling fluidization, categorization of solids. The ease with which a powder can be fluidized by a gas is highly dependent on the properties of the particle. Whilst it is not possible to forecast just how a given powder will fluidize without carrying out tests on samples, it is possible to indicate some trend. In general, fine low-density particles fluidize more evenly than large dense ones, provided that they are not so small that London van der Waals attractive forces are great enough for the particles to adhere together strongly. For very fine particles, these attractive forces can be 3 or more orders of magnitude greater than their weight. Generally, the more nearly spherical the particles, then the better they will fluidize. In this respect, long needle-shaped particles are the most difficult to fluidize. Particles of mixed size will usually fluidize more evenly than those of uniform size. Furthermore, the presence of a small proportion of fines will frequently aid the fluidization of coarse particles by coating them with a lubricant layer. In classifying particles into 4 groups, the classes into which powders are grouped are given table 6, which is taken from the work shortly. هنا عندي جروب A typical particle size من 30 ل 100 مايكرومتر، ثانية من 100 ل 800، وبعدين هنا جروب C 20 وده 1000. هنا fluidization per powder بالنسبة للباودر كريت هو examples of materials. هنا cracker cutter وده اللي يهمنا في البترول. Particulate expansion of bed will take place over significant velocity range, small particles size and low density. Rho طبعا السوليد أقل من 1400. Bubbling occurs هنا بنوع تاني bubbling occurs at velocity أكبر من F. Most bubbles have velocities greater than interstitial gas velocities. No evidence of maximum bubble size as I said. Group C or flour طبعا حجم صغير. Fine silica, fine cohesive force, difficult to fluidize and readily form channels. الآخر ده الهويت تحبي all but suggest bubbles, all largest bubbles rise at velocity less than interstitial gas velocity can be made to form spouted beds. ده نوع معين تاني. Spouted beds, particles large and dense. هنا طبعا علاقة بين particle size و density difference. ادي جروب A و B و C، طبعا C في الآخر خالص تحت. The spouted bed represent the ultimate in channeling in a fluidized bed. Gas enters at the conical base as shown in figure كذا with much of much of it flowing rapidly upwards through a center core. ده متهيألي كفاية على كده بس كده.